What we're going to do in lab today is walk through a two-way ANOVA between group ANOVA, and we're going to use the survey.save file that's in Canvas. So why don't you pull that up if you haven't. And what I'm going to do is I'm going to actually walk through the steps of the procedure and then interpret the output. And what I want you to do is keep the video in one window and then work on SPSS in another, and then just follow the steps as we go through the video, pausing the video as needed to make sure that you're doing things right. Okay, so I've pulled up the survey.save file, and I'm going to go under Analyze. Okay, and we're going to go down to General Linear Model, and then let's just pick up the univariate screen. Okay, and we'll have over on the left all of the variables, and what I want you to do is pass over into the dependent variable the total perceived stress variable. So this is a total score on a survey about stress that people have in their lives, and higher scores mean that the person is experiencing more perceived stress. So this is going to be at the bottom of this list. So go down to the bottom, pass it over. And then in fixed factors, we're going to have two between group factors. One of those is called age three groups. And basically in the data file, what the researchers did was that they binned together or grouped together folks along three age group lines. And so there's going to be three groups, and then pass over sex for male and female. So this is a 2 by 3 between groups ANOVA. Okay, so once you've done that, then we'll come over here to the right side and all of these choices on this side. We're not going to use all of the choices. So for example, under model, we don't really need to be concerned with any of this. We're going to do a full factorial model, so we'll skip that. When we come under contrasts, we don't really need to do any of these, so we'll skip that. Plots, though, we'd like to plot out changes in mean levels of stress, especially by group and differentiated by sex. So we're going to put across in the horizontal axis the three age groups, and then the lines of the graph will be sex. Okay, and then I would click add, and it's going to show up down here. I just ran through this before I started the video, so it's already there. Okay, let's see what happens. So I click add again. There it is. So it's still there. Okay, so that adds it in. We'll continue. Then we go to post hoc test. Now keep in mind, sex is just two conditions, male and female, so there will be no post hoc test there. But for age group, we definitely want to have a post hoc test. And what I would say is check off Tukey and Bonferroni. Usually I run two. You don't have to run more than one. For example, you just run Tukey. But like I've said in class, if you get a marginal F ratio that's statistically significant, sometimes Tukey won't detect where the differences are. So if you run Bonferroni in addition with it, usually it'll pick it up. And then sometimes I'll even run three of them, just in case. But again, it doesn't really matter how many post hoc tests that you run, because that's not where we find statistical significance, right? Statistical significance is found with the F ratio. So you could run all of these tests and find out where the mean differences are, but as long as you have an F ratio that is statistically significant, that's the main result. Okay, these are just the clarifying post hoc tests to tell us where the mean differences are. Okay, that led to the significant F ratio. So we'll click continue for that. We'll come down to options. And for these options, essentially we're going to pass over all three of our, or two of our main effects. The age group and the sex factors will have one main effect each. And then there's our interaction effect. We're going to pass those over here to display means. And then we're going to just say, okay, do a Bonferroni test to look at the means within those factors, and then come down here to display. We'll say descriptive statistics, yes. Estimates of effect size, sure. Observed power, as I mentioned in class, probably the least useful, but I still like to check it off just to see how powerful the detection was for the significant F ratio. And then the homogeneity test, Levene's test, is right there. So just make sure that all four of those are checked off. Okay? So click OK, and this will run the ANOVA, 2 by 2 ANOVA, and up comes our result. Okay, here's the syntax that runs the actual event. Now, SPSS does allow you to do this in a completely non-menu driven way. It's a whole different learning style. And if you go to grad school and are interested, this syntax style gives you a little bit more control over how to run the analyses than what you do with the menu system. But at this level, you don't really need to know all the syntax. Okay, so then we move to univariate analysis of variance. This is where our output for the 2 by 3 comes in. So between subjects, here we go, age by 3 groups. Here's our ends. Here's how the ages were broken up, 18 to 29, 30 to 44, and 45 plus. And then by sex, males, females. So we have 184 males, 249 females. We then get some descriptive statistics that breaks down by age group and by sex, giving us means effectively for each of the cells. So, what we'd be doing here is, just kind of looking and say, hey, does anything pop out at us right away? One thing that pops out to me as I'm looking at these results is I've got means here that are pretty close to one another, but then they spread out here and they're a little bit more spread here. So by the time I get down to the total, I do see a difference between males and females in those means. The question is going to be whether or not that's large enough to be statistically significant. And there's no way I can tell just from this table. If I look at age groups, I see 27.53 for the 18 to 29 year olds, 26.54, 26.06. There's a little bit of a difference right here. So we might see something with age group, but I'm thinking, is that large enough to really deviate and give me a significant F ratio main effect for age? Maybe. It's going to be close if it does, given what I'm seeing in the standard deviation here. Okay. But when you have large n's, the standard error is small. So sometimes you can get, with larger n's, statistically significant results that have very small effect sizes. Okay, they're reliable differences, but there's really not a huge effect there. Okay, so we come down to Levene's test of equality of error variance. What we're looking for here, again, is a non-statistically significant result. We get 0.253. That is non-significant. So the assumption of homogeneity of variance across all the conditions seems to be met. Okay, and so then we come down to our ANOVA table. Again, lots of printout. If we look across the first row at the p-value, if this is less than 0.05, then we have something significant going on in here. We just don't know where. Okay, and this is now 0.01. So yeah, there's something statistically significant. That then takes us down to these 3 rows, age group, sex, and then age group by sex. And typically I'll just start with the interaction effect and look across, and you see a 0.419, a non-significant interaction effect. So there's no interaction effect. But when we look at sex, we do get a p-value less than 0.05. In fact, it's at 0.004. That is statistically significant. So we have a main effect for sex. Do we have a main effect for age? We look across, 0.07, no. It was close. Remember, we were looking and saying, it might be there. It was close, but it didn't quite make it, so 0.07. So we have one main effect in the data, and now the real question is going to be, where do we see that effect? And with 2 groups, it can only be between males and females, right? So everything that follows now is going to be just a little bit anticlimactic because we already know where the groups are, and SPSS is not going to run post hoc tests if there's only 2 conditions or 2 groups. Okay. Overall effect size, partial eta squared. This is the amount of variation in sex that uniquely contributes to variation in total perceived stress. That's coming in at about 0.019. If we round to 0.02, that's going to be a pretty small effect size. Okay, so there's a relationship there. We are seeing mean differences that are statistically significant from one another, but the overall effect of that, the total effect size, is fairly small. Okay, so if we come down now, we'll hit estimated marginal means, and it's going to treat each of our factors separately. So here's sex. There's the mean for the males, mean for the females. Okay. It will do the pairwise comparison right down here just to show you that there is a statistically significant difference. You don't really need that because obviously it can only be between males and females. And you'll see that the significance level is at 0.004, which is the same as what you see right here in the F ratio, right? So the fact that these are exactly the same tells you that you really didn't need to run that pairwise comparison. Okay, it'll give you a table that will show the means broken down age by the three groups by sex. Nothing really there to look at. And then it'll do the same analysis, but for the three age groups. So here's our means for each of the three age groups, 18 to 29, 30 to 44, 45 plus. So you'll see that they are different, right? But it did not reach statistical significance. Now, it's going to go ahead and run the pairwise comparisons anyways, just because SPSS will automatically do that. But you'll notice none of these are below 0.05 in the p-value column. Okay. All right, we can skip the next table because this is just telling us that there was a non-significant effect. It's no different from what we saw earlier. So here's the 0.071, which is the p-value. Okay, and then we're coming down to the post hoc tests. Nothing really there to look at because, as I said, there was nothing significant for the three age groups. So when we look at over here, we're not going to see anything below 0.05. We can skip the homogeneous subtests or subsets. And the last thing left in the output then is the profile plots. And so this is showing that the lines have sort of separated between males and females. That's reflecting the main effect for sex, right? Is the separation here. But the lines for the most part look fairly parallel. They're sort of sloping in the same direction. And what that's showing is as people get older, they're experiencing less stress. Now, one of the questions might be, well, hey, this is a range of 11 years. This is a range of 14 years, right? 45 plus could go all the way up to the top. So maybe we need a better analysis of the data by breaking down the age groups